Hello everybody and welcome to day 8 of Advent of Code 2023. We will be solving today's puzzles in C# again, and let's get started on it. So we're still riding the camel across desert island and we spot a sandstorm quickly approaching. We have some map in the camel's pouch, and we need to figure out how to navigate a network of labeled nodes. So we have left-right instructions to navigate the network, and we on the input get some kind of so we started at node AAA, and we are heading to ZZZ. So okay. We need to look up the next element based on the next left-right instruction. So we have right-left instructions, and so if we have R, we need to go to the right element of A. So it's CCC. Then L means we have to go to the left element of CCC, which is ZZZ. So then we have reached our destination. But we might not find ZZZ right away. So we need to repeat the whole sequence in case it doesn't happen. So we need to take 6 steps of LLR to get to ZZ. Okay. How many steps are required to reach ZZZ? Okay, so that seems reasonably simple. I'm not sure what's gonna be the catch in there, but let's try to solve this. So I will set day 8 as the default project, and then so there's a lot of steps there. That's the first thing we need to notice. But anyways, I will read the input. So I will use using parse stream file open. Oh, we are in the wrong project here, so we need to be here. So file open input txt, and now we use our reader, which is going to be new stream reader on top of input stream. Now what we do is first read the instructions, which are on the first line, right? Yeah, so let's read the first line. Directions. Reader read line. Now we read the empty line, so reader read line, empty line, and now we will read the network instructions. So for while reader read line is line, we go like this. So we split the line into parts, split by equals sign. Now it's gonna be part 0. So node name is gonna be part 0, and we need to make sure we trim it. And so destinations, maybe I'll create a class node which will have string name and string left, string right. So it's going to be a simple record for now. So it's going to be here, part 1, trim, and I will also trim these characters and split by this one, yes, and var left destinations 0 trim, and var right will be destinations 1 trim. So this should give us the right and left, and now we create a node. So our nodes is going to be new dictionary of string node. And while we have this, we'll have node new node node name left right, and now we add it to the nodes list. So node name equals node. All right. So now we have the input parsed, and now we go process the directions. So while our current node equals AAA. So while current node is not equal to ZZZ, we will be processing the instructions. So current instruction equals 0. So we get instruction directions instruction current instruction plus. So we move to the next one in the meantime. So modulo directions length maybe. Oh, so directions modulo equals directions length. So we loop back to the start when we are out of the bounds. So this is just a cleanup, and now we yeah, so this is always not null, and now we will apply that movement. So find the current node, and if instruction equals L, then we go current node equals node left, and otherwise current node equals node right. Very simple, but it seems to be all we need. So we'll count the steps starting by 0. So steps plus. And now let's see if this works. So console write line steps, and I will test it against the first simple input, this one. So this one should be just, oh, we have some build error there. Not open read. Right. Just 2. So very simple. This one worked out completely fine. Now let's try this more complicated one. It's 6, which seems that it could be correct. So now let's try with the big input, and let's hope it will work out as well. So 18,673. Let's hope, and it is correct. So we have first part of this problem finished. So now let's switch to the second one. So here's the part two, and I had to handle this one a little bit differently because I tried it, and my original solution was a brute force algorithm, which didn't work because it was taking years to finish. And actually, the solution to this one is kind of specific because it depends on the input files structure, which is specifically done to actually handle this properly. So I will explain how my solution works, and I will show you if it works. But I think it's very likely it's gonna pass this time. So the summary of the second part of the problem is that we are starting in multiple locations, not just one, and we are shooting for all of these starting points to continuously move and reach the the nodes with which end with z at the same time. So we start with all the starting points that have a at the end, and our goal is to reach z ending nodes at the same time. So this would be a very complicated problem because if you were to brute force it on the big input, it would take a huge amount of time to finish. Or if it was a general input, every of those starting positions could go through a number of different nodes which end with a z, so multiple of them, and also then reach a loop which would forever repeat, and you would have to calculate kind of the lowest path to reach all the loops, and then calculate the position of each of the z and nodes in each of the loops, and then calculate the lowest common denominator across all of those options, and it will be a mind-blowingly complex task. However, the puzzle input that you get here is kind of specifically adjusted so that this problem is simple enough. And that is by making sure that each of the A starting points reaches the Z starting, reaches the just only one Z in its path, and that Z position is actually reached in a number of steps which is equal to the size of the loop that specific path will then continue on. So essentially the Z step loops back to the second step in that specific path, so that it means that the loop is always of the same size as the number of steps it originally took you to reach Z. So when you reach a node with which ends with Z, you can take the number of steps, and that's the size of the cycle that this specific path will take. So once you have the cycle sizes for all of those starting points, you can then calculate the lowest common multiple of those. And the lowest common multiple is a normal algorithm that you might know from school. It's just taking the multiple of those two numbers and dividing them by the greatest common divisor, which is again another algorithm that is just basically taking the modulo of numbers and going down until it reaches until one of the two input numbers is 0, and then the other one is the lowest greatest common divisor. So this algorithm, when it's run, finishes very fast because it's just going through each of the starting points and calculating that loop once, and that result is actually correct. So this one was a weird day, because if the input was not structured in this simple way, it would mean that this whole problem would be much more complicated. Luckily, it wasn't that way, and the solution was in the end kind of simple, but still it is more is probably nicer when the problems are do not depend on the input file structure. And this is something that wouldn't probably happen in like programming competitions where you must expect any general input and your solution must handle that. So in this case, the input was specifically done to make the solution easier, but yeah, it is not a general solution. It would not work in general case. But anyway, this is the solution to day 8. I will push everything to my GitHub so you can see that and run it locally as well. And yeah, that's it for today. Please leave me a subscribe if you want to get notified about new videos, and I will see you in the next video for day 9. Oh right, and I will also publish another video for ChatGPT versus day 8 of Advent of Code. So I will see you there.